A statically indeterminate frame, such as one with fixed base, can be analyzed as portal frame when subjected to lateral load. The behavior of portal frame is governed by hinges that indicate the point of inflexion for deformation curve. Those points are placed at the center of column and girder, where the bending moment is assumed zero. First, we determine the shear force developed in each column. To do so, we divide the lateral load evenly for each subframe. For instance, consider a 3-bay frame subjected to 12 kN of lateral load. Focusing on the top level, the frame can be converted into the superposition of 3 subframes where each of them needs to sustain 4 kN of force. As a result, 2 exterior columns are experiencing 2 kN shear force, while the remaining 2 interior columns are resisting 4 kN force. Note that these forces are acting on the column hinges. After determining the column shear force, we can dismantle the frame at column and girder hinges. We first analyze the part that receives the lateral load. Using 3 available equilibrium equations, we can determine the remaining 3 unknown forces in hinges at this part. By taking equilibrium in x direction, Ix equals to 10 kN. Then, by taking moment about column hinge E, Iy equals to 1.5 kN. Finally, by taking equilibrium in y direction, Ey equals to 1.5 kN as well. After we solve for the first part, we proceed to the adjacent part and carry over the hinge I forces. The number of unknown forces remains 3, and they can all be calculated using equilibrium equations. The process continues until we solve for the entire frame. Portal method is good to use for uniform frame with low elevation. Under this condition, the frame response is governed by shear force. When neither of the frame condition is fulfilled, we may use cantilever method instead. Let's say the frame we have now consists of 2 types of columns with different cross-sectional area. The assumption of hinge is the same. However, we are now determining the axial force developed in columns rather than the shear force. First, we determine the centroid of column cross-sectional area at the top level. Moment induced by lateral load about this centroid is counteracted by the moment due to the axial force in the columns. Knowing the lever arm of each column from the centroid, we can form an equilibrium equation. Imagine the structure is divided by the centroidal axis. The columns are in tension if lateral load is exerted on their side of centroidal axis. On the opposite side, the columns are in compression. The magnitude of axial force in a column is proportional to its lever arm. Therefore, by using similar triangular correlation, we can simplify the equilibrium equation and make it consist of only one unknown. After solving the unknown, we can use it to determine axial force in remaining columns. Up next, the procedure is similar to portal method. The frame is dismantled at hinges, and the unknown forces are solved part by part using equilibrium equations. Thank you for watching. If you find this video helpful, please share it with your friends. We'll see you guys soon. Goodbye.